for our last couple examples in this target, we're going to talk about how we can prove that two triangles are similar to each other. Now, we're not necessarily going to write a formal two-column proof like we did with congruent triangles, though we certainly could. Rather, we're just going to kind of informally talk about this. However, we have to make sure that even though we're not doing a formal proof, we're still explaining our reasoning at each step. We can't just add tick marks because we want to. And so in order to prove that two triangles are similar, we've come up with 3 total shortcuts recently. We've talked about AA, similarity, showing that two angles are congruent. We can also show that 3 sides have the same ratio. Not that 3 sides are congruent, but 3 sides have the same ratio. Or we can show that 2 sides have the same ratio, with the angle in between those sides being congruent. So those are the 3 different methods we can use to prove this. And so I guess let's kind of begin with how we started last time. Add any tick marks that we can. Looking at this diagram, I see that I have vertical angles right there. And so if you're writing this out, you probably want to make a note about that. That the reason you added those tick marks is because vertical angles are congruent. Again, if you're writing a formal proof, make sure that you include your statement, something like angle ACB is congruent to angle DCE, because vertical angles are congruent. But like I said, we don't necessarily have to do a formal proof for what we're doing right now. So that's the only tick mark I can add for angles. I can't do anything for the other angles, which means AA is out since I can't prove a second angle. But I have 2 other options to use. Although I'm guessing that since nothing is labeled on that third side, side angle side is also out as well. So I'm left really with 1 option. But that's okay, because that's the one that I'm going to need. And so to do side angle side, I've got my angle. Let's match up sides. You'll recall that we matched up the long sides and we matched up the short sides. And we weren't looking to see that they were the same, we were looking to see that they had the same ratio. And so the longer side from the triangle on the left is 18. The longer side from the triangle on the right is 30. These triangles have been flipped around. Simplifying that by dividing both the top and bottom by 6 gets me 3/5 as that ratio. That doesn't tell me anything just yet. I've got to see if the short sides have the same ratio as well. The short side from the left triangle is 9. The short side from the right triangle is 15. Dividing each of those by 3 gets me 3/5. And so if I take a look at what I've done, I've shown that 2 sides have the same ratio. I'll probably make a little note about that. They're the same ratio, which is what I was looking for. And more importantly, the angle in between them was congruent to each other. And so that can be sort of my informal proof of why triangle ABC is similar to triangle DEC. I've got 2 sides with the same ratio and the angle in between them being congruent. So these are similar because of side angle side similarity. Let's take a look at one more example and see if we can figure out this. Again, we don't have to write a formal proof, though we can if we want to. Let me see where these triangles are, because I've kind of got some overlapping triangles. I don't know which one I'm quite looking at yet. So XZW is one of them. So I want to prove that that triangle is similar to triangle YZX. So this one over here. So I'm looking at the 2 smaller triangles. This time I have one angle matched up. I've got those 2. Although it doesn't look like there's any other angles I can use. So my thinking is probably side, side, side similarity. If I can use that to show that all 3 sides have the same ratio, I should be able to get the 2 triangles similar to each other. And so to do this, kind of like we just did, let's match up the short sides. Compare those to the middle length sides. And then finally compare the long sides. Okay, I'll need all 3 of them if I'm going to use side, side, side similarity. And so let's just go triangle 1 and triangle 2, I suppose. So the short side from the first triangle is 12. The short side from the second triangle is 9. Just be careful. They're kind of spun around on you. Simplifying that gets me a ratio of 4/3, which doesn't tell me anything just yet. I need to go through and match up all the sides. The middle length side is 16 from triangle 1 and 12 from triangle 2. Once again, that simplifies to 4/3, so that's a good sign, but it's not done yet. I need to match up all 3. The longest side of triangle 1 is 20, and the longest side of triangle 2 is 15. I cross my fingers as I simplify that. Dividing both of those by 5 gets me a 4 and gets me a 3. And so what I can do is say that, look, all 3 of these ratios are the same. All 3 sides have the same ratio. That's exciting, so I'll add an exclamation point this time. And that's actually all I need to do to prove that the two triangles are similar, because they all have the same ratio between the sides. They are going to be similar to each other. Not a formal two-column proof, but it's enough to prove they're similar for what we're going for right now.